on this third page, there were some things that I expected people to have a little bit of difficulty on, and there were other things I thought people wouldn't have that much difficulty on, and I don't know. I always get surprised by those things, but I suppose, like I always say, you have to, there are 3 reasons that we give assessments. We need to give you a grade. I guess that's part of the process. I need to find out what you know, and you need to find out what you know. So here we're given a graph of g, whatever. The graph of g is shown above. F is the definite integral from 1 to x of g of t dt. And let's see. Remember, the input to f, the function that gives you the area, the input is x. And we can't have that same x inside of g because we don't want the shape of g to change. So we need what's called a dummy variable. That's why the t is in there, just so it doesn't match x. Okay, we're going to evaluate the following or explain why the result does not exist. I guess one thing to note, if you're going to say something does not exist, it should be like no one should be able to do it, not you're a little bit confused. That's usually a harder thing to explain. But, okay, here we go. So f of 1 and f of 6 are the same type of thing. I think I'm going to have to zoom out because we want to be using this graph the whole time. I think at the bottom I'm going to have to zoom or scroll back and forth. All right, so f of 1, that's going to be, you don't have to write this, you could just think it, but I might as well write it out. F of 1 is the definite integral from 1 to 1 of g of t dt. Now a lot of people said this was impossible because there was no area under this graph starting at x equals 1 and going to x equals 1. And while that's true, that doesn't mean this is impossible. What it means is f of 1 is 0. But if you wrote out that explanation, that obviously shows you know something, and so it definitely was not, hey, no points or no information. Okay. F of negative 6 is the definite integral from 1 to negative 6. Notice that's 1 backwards to negative 6, so things are not quite in the right direction, of g of t dt. So a couple of ways to go. I need the areas, and because we get 2 different line segments, my brain goes to, we'll break off into 3 triangles instead of 2. Some people got the area of this triangle wrong because, I don't really know why, but whatever. So the first thing I notice is this triangle right here is 2 units wide and 6 units tall. This triangle is the exact same size. So no matter what, those 2 signed areas are going to add to 0. So all I really need is the area of this triangle, which is 1/2 of, let's see, negative 6 to 5, 4, 3. 3 times 6. And so that just has an area of 9. I never bother writing in the numbers because depending on whether we're integrating left to right to left, the numbers change. And so what am I saying there? If I did the definite integral from negative 6 to negative 3 of g of t dt, as in if we were integrating from left to right, that would be equal to negative 9. But because we're integrating right to left, we end up saying that f of negative 6 is positive 9. Okay, let's do that again in another way. I assume if you're watching this, you want more information, not just how to do it, but who the heck knows. So the other way would be 9, 6, and 6. So we could break this integral up. Maybe we do the definite integral from negative 6 to negative 3 of g of t dt plus the definite integral from negative 3 to negative 1 of g of t dt. Oh man, always run out of room. Plus the definite integral from negative 1 to 1 of g of t dt. And of course that's equal to the definite integral from negative 6 to positive 1 g of t dt, like the whole thing but in the reverse order. Remember, we're integrating from 1 to negative 6. Oh man. Integrating from 1 to negative 6, not negative 6 to 1. And so if we were doing that, the integral from -6 to -3 of g of d dt would be -9, because all of these changes in x are positive, all the y's are negative, and so we get a signed area of -9. Likewise, the integral from -3 to -1 g of t dt is going to be -6, and the integral from -1 to 1 of g of t dt is +6. So notice the algebra works out. The -6 and +6 end up adding to 0, and we just get the integral from -6 to 1 of g of t dt is 9, which means if we wanted the integral from 1 to -6 of g of t dt, we would have to put a negative out front because we switched the bounds, and that would be a -9. Okay, that was kind of a lot. How do I erase? Maybe I can do it with the mouse. I'm not sure if that's easier. All right, so let's think about the next part. We want f prime of 1. And you don't have to, but I recommend doing, how do you say it, the generalized version first, as in not f prime of 1, but f prime of x. So maybe we'll just write it up top. You know, f of x, I won't do it up top there. I'll do it right here. F of x is the definite integral from 1 to x of g of t dt. If I want f prime of x, I take the derivative of the left side to get f prime, and I take the derivative of the right-hand side, and that's just fundamental theorem stuff. The derivative of the integral is the function in the integrand, but with an x inside. You don't have to worry about the chain rule. If you did, you'd be multiplying by 1 the derivative of x. Okay, so that's what we're thinking here. So f prime of 1 is the same as g of 1, which means f prime of 1 is equal to, oh man, I did what you guys do, zooming in and out. G of 1 is just 6. It's just the y value of this graph at 1. And so on the other end, f prime of 6, that's going to be the same thing as g of -6, which means f prime of -6 is the y value of this graph at -6, 0. All right, and then we get to, I guess, the ones people miss most. I don't know if they're the hardest, but you know, when you're doing a lot of things at the same time, this stuff gets difficult. Let's see, can I zoom out enough? And we're going to need a thinner pen. Okay, so f double prime of 1, well, maybe we go back up top. If f prime of x is g of x, then f double prime of x is g prime of x. Oh, and f double prime of 1 is g prime of 1, which means f double prime of 1 is the slope of this graph g at x equals 1. And what you're supposed to recognize is, oh, that's what we call a corner. Right? That's a place where the two slopes on the left and right hand side don't match. And so you can say f double prime of 1 does not exist. And you know, that's good, but if you have to explain why the result does not exist, that's harder than most people think. Because just like with continuity, you can't just do a graph-based argument. You're expected to do a calculus-based argument, kind of weirdly using the graph. Okay, so what are we going to do? Well, does not exist, I'm using that phrase on purpose, and that should remind you of limits. And what we need to do is a derivative without using g prime. Our evidence is the graph of g. Okay? So what we're going to do is an alternative form of the derivative. Limit as x approaches 1 from the left of g of x minus g of 1 over x minus 1 equal to the limit as x approaches 1 from the right of g of x minus g of 1 over x minus 1. Because that's basically saying what we're looking for is slope of a tangent line at x equals 1. And what we don't want to do is use a limit on g prime of x, because we don't have a graph of g prime of x. that math is going on in your head, right? We have a graph of G. Okay, anyways, so this piece on the left, we actually already know these are not going to be equal. This piece on the left, the limit as x approaches 1 from the left, g of x minus g of 1 over x minus 1, is the slope of secant lines where that second point to the left of 1 is getting closer and closer to the point at 1, which is actually just the slope of this line. And you can count that off, that this is a slope of, let's see, 1 to 1, that's a change of 2. Up to 6 is a change of 3. So what is that? Or 6. That's a slope of 3 overall. On the right-hand side, that's a slope of 0. And because those slopes don't match, the slope of this graph G at 1 would not exist. That's kind of a lot. Now the other one, this slope does exist. There were quite a few people that said f double prime of negative 6 doesn't exist because we don't have a graph of whatever. And what you're supposed to figure out is, well, we need the slope of this graph G at negative 6. And again, you just can kind of count that off, that this is a slope of negative 2. You know, down 6, to the right 3, that's a slope of negative 2. Oh, I understand why you people scroll up and down so much, but I don't know. The sideways version of this is hard to do. Most people did pretty well on this. What we're looking for, now number one, we have open intervals. We're not considering the endpoints. You'll see that on the next page when you do extreme value theorem. Find the x-coordinate of all local maximums and minimums of f on negative 9 to 9. So we should probably mention continuity. We haven't done that. We should say g of x is continuous because f of x is continuous. Nope. Not because. I have it backwards. So, f of x is continuous. Okay. And then what we're looking for is where f prime, which is the same as g, changes from positive to negative. That's negative 6. And where f prime, which is g, changes from negative to positive. That's negative 1. Okay, so that's what we say. So f prime equals g, changes from positive to negative at negative 6. And I think the best way to go is every time you talk about f prime, you talk about g, because it's like, hey, I want f prime to be my evidence, but the evidence I have is a graph called g, which doesn't necessarily sound like it's attached to the function f. Anyways, f prime, which is g, changes from positive to negative at x equals negative 6. So f of x is the thing that has a local maximum at x equals 6. A lot of people, not a lot, plenty of you left off f. You said like, hey, there is. Now in this case, because the instructions say, hey, find the x-coordinate of all local maximums and local minimums of f, you're probably fine because you're not asked about, hey, just find maximums and minimums, but it's clear you're not thinking about the function that has the minimum. This is it changes from positive to negative, so it has a maximum sort of thing. We always want to be specific. If you're non-specific, it's likely you're actually not thinking clearly and precisely about what you're writing. And so if you remember, we noticed that f prime, which is the same as g, changes from negative to positive at x equals negative 1. So again, f has a local minimum at x equals -1. And I'm noticing, sorry, my brain is going 3 places at once. I was noticing that the -6 is not a -6 down below. There we go. The last one, I think I'm going to look for or think about what I want before I go back and look for the evidence, which is what I normally recommend anyways. So on what open intervals, you know, there are plenty of people that wrote closed intervals. With concavity, you actually have to always have open intervals because of the definition of concavity. You know, a graph is concave up, where the tangent line lies completely below the curve on the left and right hand side of the points of tangents, the point of tangency, and that can't happen at an endpoint, but whatever. Okay. F is increasing, and then I'm going to leave concave down blank for a second. But let's see, that's enough room for concave down. On intervals where, well, let's think about this. What would our evidence be? F increases where f prime is greater than 0. Okay, but I don't have f prime. I have a graph of g. So I'm saying f prime is what I want. I want g, or I guess I have g, to be positive. You could also say above the x-axis. I think it's actually going to be better if I use the word positive. And then let's change colors here. F is increasing on intervals where f prime, which is the same as g, is positive, and f is concave down. On intervals where f equals g prime is decreasing. You can't say f double prime equals g prime is negative on its own. You can say that, but you don't have a graph of g prime. And so really what you are looking for, whether you realize it or not, we are looking for where this graph is decreasing to figure out where g prime is negative. So you actually have to make that connection. This is the sort of thing I mean when I say your job is to show what you know. Anyway, oh my gosh, vertical is hard. Okay, so we are looking for where this graph, f prime equals g, is positive or above the x-axis and decreasing. And that is from -9 to -6. You can actually include the -9. It did say open intervals, so you're safest to say this occurs on the open interval, -9 to -6. I hope that helps.